Howdy, howdy, howdy. We're talking algebra, and this time we are combining like terms. And before we really do anything here and talk about what the heck that means, you're going to press pause on this video, you're going to go back to Classroom, and you're going to click on this video for combining like terms, Mad TV, ridiculous fast food order. So this is a sketch from, it's not around anymore, but Mad TV. It's kind of like Saturday Night Live, but better, I think. Yeah, watch this skit. So pause this video, go to this one and watch it. I'll wait. All right, welcome back. Okay, so ridiculous, right? So like a super long, complicated order. I love how the employee somehow hears all that and remembers it, but as if that was possible, right? So why the heck are we watching that? Well, number one, Mad TV is amazing, and we should remember it. And number two, more importantly, it's a good example of when you should combine like terms. In real life, we should be combining like terms. Like these people did not. Okay? So, what the heck does that mean? Well, here we have an expression right here. Okay? And notice there's kind of like an orange box around this guy and this guy. There's a green circle around these two guys, and then there's a purplish red, pinkish red, whatever, diamond around this guy. Okay? I want you to imagine that these are kind of like the items he was making in his food order. Okay, so let's imagine every single time we have a term that has a Y a part of it, let's say that's a burger order. Okay, we got a burger order over here. Let's say every single time we have a green circle that's like a drink. Okay, so he's ordering a Coke. Oh, we got more Cokes over here. Cool. And let's say the diamonds, let's say that's like your fries. Okay, so what we can think of this is like, hey, I ordered 8 burgers, okay? And then later on in my order, I ordered another burger. Well, how many burgers do I have in total? I have 9 burgers in total, okay? And then I'm gonna look at the drinks. Let me just get the right color. The drinks. I ordered 3 Cokes, and then later on in my order, I ordered another 2. Well, how many drinks could I have just said? I could have just said, hey, 5 drinks. Okay, and I can combine those numbers because they're talking about the same thing. Drinks, combine them together, we have 5 drinks, okay? And then lastly, in my order, I said, hey, I want 4 fries. I didn't say anything else about any more fries later on, so I've got 4 fries. Let's see if I can make a diamond, probably not. Ugh. Okay, there we go. So yeah, it's combining like terms. It's the same thing as making a fast food order, and you could say, hey, I want 2 cheeseburgers, 2 fries, 2 more cheeseburgers, 5 more fries, 2 Cokes, 3 more fries, 3 more burgers, and 1 more Coke. It's really complicated and unnecessarily long. We can combine that so it's more simple. In other words, simplify the expression by combining like terms. Okay? What I like about this worksheet is that it gives us a visual, right? It uses colors, it uses different shapes to show us where the like terms are. Do you need to do that for every single expression? Absolutely not, but I encourage you to, for the first couple at least, because that's going to help your eyes visually see where the like terms are. I prefer just kind of underlining. So in this expression, let's see where the like terms are. Well, I see a couple constants, and remember constants, they have no variable attached to them. They're just a number, and they're constantly, like this, 3, it's constantly 3. It's not going to change. There's no variable. It's just 3 all the time, constantly 3. Same with 1. It's constantly 1. So I know those 2 constants, I can combine them together because they are like terms, okay? 3 and 1, they're both positives. They'll add together. They will combine to become 4, okay? Next, I'll use a different color here. I see 4x, so it's the coefficient 4 is multiplying with the variable x. This is one term together. I'm going to use a wavy line for it. Okay, are there any other terms with x? Yep, right here. And we can pretend that x represents burgers, right? I've got 4 orders of burgers, and then another 2 order of burgers. How many burgers do I have? Well, I've got 6 burgers. Okay, and 4 was positive, so a positive sign will come down. And boom, we have simplified this expression by combining like terms. Now you might be asking yourself, well, how do I know if a term is like another term? Well, if we look at B over here, we've got 4 terms. 1, 2, 3, 4. And I know these are terms because they're separated by an addition symbol or subtraction symbols. There are no subtraction in this one, but if a little island of numbers is separated by an addition symbol or a subtraction symbol, we could say that those are terms. So 4 separate terms. Okay, good. 3a, 2b, 8a, and 4. Well, I see 2 terms that have a's. So I know those will combine because they are alike. They have the same variable, so they are alike. I've got 3 a's and 8 a's. How many a's in total? Well, they're both positive, so they won't take away from each other. They will combine, they will add. I have 3 plus 8 is 11. I've got 11 a's. Do I have any more terms with b's? Nope, so it just drops down. It's already combined. 2b. And do I have any more constants? Nope, just 4. Boom. Just like that. Awesome. Let's see if we can find one that has subtraction. Maybe the next page. Nope. 3rd page. Okay, there we go, all the way down here. Now, one thing that's really important when we're combining these terms is that it's not always going to be addition. Sometimes it will be subtraction, okay? And we need to think of these terms as if they're integers, because I mean, they are technically, okay? So in this expression here, I have 1, 2, 3, 4, 5 separate terms, okay? So 7a, what is its sign? Is it positive or negative? Well, remember, whenever there's nothing in front of it, we assume it's positive. So this is positive 7a. Next we have plus 3b. Well, that's the same as positive 3b. Next we have subtract 2a. And that's the same as negative 2a. That subtraction symbol needs to stick with that 2a. It has to go with it. So when I change the order of this, the subtraction has to go with 2a. Same with 5. This isn't just 5, it's subtract 5, which is negative 5. Okay, and then we've got plus b. Yeah, you betcha, that's another positive. Boom. Okay, well now let's combine these bad boys. Screen. Okay, well, let's have a look at all the a's. How many a's do I have here? Well, I've got positive 7a, negative 2a. Okay, so now we've got integers combining together. Okay, and this just works like a normal subtraction question. 7 take away 2, well, that would leave me with 5. And we're talking about a's, so it's 5a. All right, let's look at the b's. How many b's do I have? I'll use a squiggly line for that. Okay, there's a b. Nope, nope, yep. Okay, so I've got 3 b's and a single b. So 3 plus 1 is 4. So now I've got 4 b's. Okay, and then how many constants do I have? I've just got this one. It's 5. Now notice though, it's subtract 5. So the subtraction symbol has to come down with 5 with it. Okay, so don't think of these terms just as the number and the variable. Okay, think of them as the operation that goes right before it. Okay, because these are technically all integers. Okay, especially when you have that subtraction symbol in front of it, the subtraction has to go with it. And you know what? I'm going to check my work. So question A. So here's what it should have looked like. 5a plus 4b, subtract 5. 5a plus 4b, subtract 5. Perfect. There you go. Now notice my terms are all in the same order. A, B, and then the constant. A, B, and then the constant. Does the order matter? No, it doesn't. It doesn't really. What does matter, though, is that each of these terms are positive or negative. Like if they're supposed to be positive, they need to still be positive. So I could have rewritten this like this. If we want the constant first, sure. But I'm not just going to write 5. The subtraction, the negative symbol has to stick with it. Okay, and then let's go 4b. Okay, and 4b is positive. So it's like we're adding it. Okay, 5a is last. And because there's no symbol in front of it, we know that it's positive. We assume it's positive. Okay, This is the same expression as the one above it. Same exact thing. Okay, if we had the value for what A would be and the value for what B is, they would simplify to the exact same thing. Okay, now that all being said, the order doesn't matter. I don't really care. But typically what we'll see in math when you're organizing your operations, the alphabetical order of your variables often dictates how you organize it. So like notice A comes first and then B. If we had a C, it would follow, and then if we had a D, it would follow. So typically that's how you'll see mathematicians organize their terms in an expression. The constant comes last. So I would like you to use that way of organizing your terms. The earliest letter in the alphabet should come first and then the next, and your constant should be last. But again, the order doesn't matter. So you're not going to get it wrong if you change the order, but it is a good habit to follow that way of organizing your terms. And that's it, guys. The last thing I'll say before I let you go, the worksheets do say draw shapes to identify the like terms. Do that. Do that. It takes 2 seconds, right? Like I showed, I like doing lines. That seems to work for me, okay? So I would go for my X's straight line, my Y's would be a squiggle line. Yeah, like that works too, right? If you don't like doing lines, heck, squares for the C's. Okay, and then I'll do circles for the D's. And then nothing for the constant. It's really up to you. It's how you want to organize, okay? But doing something visual like this can really help us see what terms are like and which ones are not, okay? Have fun with this one, guys. Good luck. See you next time.